Right, so question 8 on the 2015. Right, so this is, you're expecting one of these types of questions where you have to take data from a text and put it into a flowchart. Okay, so what we have here is sodium carbonate is used in the manufactures of soap, glass and paper, as well as the treatment of water. One industrial process used to make sodium carbonate is the Solvay process. Okay, and then you've got a picture for A, and it's on the right hand side. Use the information, complete the flowchart by adding the names of the chemicals. Okay, so you then just work your way through each one. It starts with heating calcium carbonate to produce carbon dioxide. Okay, so we've got our initial one. We've obviously got to have our calcium carbonate in here. Okay, to produce carbon dioxide, which is transferred to a reactor where it reacts with ammonium and brine. Okay, so we've got heating produces our carbon dioxide, which is transferred to the reactor where it reacts with ammonia, must be up here, and brine. The products of the reactor are solid sodium hydrogen carbonate and ammonium chloride, which are passed into a separator. The sodium hydrogen carbonate is heated to decompose into the product sodium carbonate. So we are going to put the sodium hydrogen carbonate in here. So I'm not going to try and write that out in that space, which means our ammonium chloride is going here. Okay, heating of this one, sodium hydrogen carbonate, decomposes the product sodium carbonate along with carbon dioxide and water. So I get my sodium carbonate out here, and I get my water here. Okay, we've got ammonium recovery, which goes to calcium chloride and ammonia solution. So our heating here with our carbon dioxide must also produce our calcium here, which is going to the ammonia. Okay, sorry, not just straight calcium, calcium oxide. Okay, when you heat it, if we do an equation, here's our calcium carbonate, here's our carbon dioxide, we are left with calcium oxide. Okay, so that's got to go up here. It's quite a lot of work, I think, actually, for the 2 marks. I've seen much simpler ones. So you're getting the first mark on the mark scheme. Let me just see where this one was. For the calcium carbonate, the carbon dioxide run here, the ammonia, and working out the calcium oxide. That gives you the first mark. And then the second mark is for putting your ammonium chloride down here, your sodium hydrogen carbonate here, your sodium carbonate, your water. So I suppose, so you're looking at 4 things for each mark. It's one of the harder ones, I think. Okay, because they don't actually give you everything in the text for you to do the calculation. Okay, right. The reaction that produces the solid sodium hydrogen carbonate involves an equilibrium. Brine is a concentrated sodium chloride solution. Explain fully, 2 marks on this one, why using a concentrated sodium chloride solution encourages production of sodium hydrogen carbonate as a solid. Let me just spin this down a bit. Okay. Right, so what you need to recognise here is that if they're saying brine is a concentrated sodium chloride solution, so that means we have this. Now sodium chloride is actually that, and if I put it into water and dissolve it, what I've actually got is an awful lot of free sodium ions and chloride ions surrounded by your water molecules, but essentially and importantly I have this, which is the same as this in the equilibrium. So what you're doing is you're going to force Le Chatelier to kick in. Okay, so what you're doing is increasing your sodium massively by dumping in a highly concentrated solution of it. Okay, so increasing your sodium ions means that our equilibrium is going to shift to the right. Okay, it's going to favour the right hand side, and if it favours the right, it is favouring the product, and that is what we're getting. Okay, so you're looking to get, so for your 2 marks, what you need to do is first of all explain what you're doing in terms of adding in the sodium ions, and then you need to explain that putting them in means that the equilibrium will shift to the right, increasing the product side. And that's the question.